Each acre of hemp, if it's grown at like industrial hemp, not CBD, okay, but if it's grown under industrial hemp, gives off about 208 million BTUs per acre. Well, what does that mean? If you converted that 1 acre then of that 208 million BTUs and you converted it to electricity as comparable to the amount of energy that's coming out, okay, it's comparable to 60,000 kilowatts of electricity. That's enough electricity to run a average clothes dryer for 24 hours a day for 27 months.
That's Nick Walters from the National Hemp Growers Co-op. And what the heck is he talking about? Well, that's what we're going to find out today on the Lancaster Farming Industrial Hemp Podcast. Hello there, my name is Eberhard, and today I'm going to talk to Nick Walters from the National Hemp Growers Co-op about hemp as a source for energy, specifically hemp as a feedstock for anaerobic digesters to make renewable natural gas. This is fascinating. It opens up a world of possibilities, and we're going to hear all about it. The National Hemp Growers Co-op is coming out with a white paper and a bunch of research over the next few weeks to explain what this is all about. So we're going to dive in deep and hear what Nick has to say about it. We're also going to have a quick check-in call with Lori Daitner from Dawn Enterprises out there in Newcastle, Pennsylvania, where they have just recently finished the Project PA Hemp Home. And we're going to hear what's happened since the last time we checked in on the project. So lots of great stuff on today's show. I think you're really going to enjoy it. And if you're keeping track of time, today is actually September 28th, 2022. All right, so mark that down if you're keeping score. All right, we're going to take a quick sponsor break, and then we're just going to get right into our interviews. This episode is brought to you in part by IND Hemp in Fort Benton, Montana, where their mission is to provide innovative agricultural products and services to connect American farmers with the pioneers and businesses that see hemp as a way to bring real and lasting change to our communities and planet. IND Hemp. This episode is brought to you in part by King's Agri-Seeds. King's Agri-Seeds knows that farming is local, and they've been screening products for local adaptation since 1993. Using their research farm in Christiana, Pennsylvania, King's is working to ensure seed varieties are fit for the East. Hemp is no different. Whether you are growing for grain, fiber, or CBD, King's Agri-Seeds has you covered. Give King's a call at 717-687-6224 or visit kingsagriseeds.com. Nick Walters from the National Hemp Growers Co-op. Welcome back to the Lancaster Farming Industrial Hemp Podcast. You were just here like a couple of weeks ago, so it's
I know
great.
you gave me a call, and I was open, and so who knew? Now it works again.
Yeah, well, this time it's scheduled. We scheduled this call because you have big news today. I think it's big news.
We do too.
But before we get to that, I wonder if you can just give me a quick introduction to yourself and to the National Hemp Growers Co-op.
Sure. We are a national cooperative made up of a very unique business model that enables our members and our investors to be involved in multiple value-added processing facilities for the various uses of hemp all throughout the country. And we are focused on building wealth for our members through regenerative agriculture and sustainable development. And a lot of this came about because of a tour of duty and that I took at the U.S. Department of Agriculture as a rural development state director in the Bush 43 administration here in my home state of Mississippi, where I learned a whole lot about co-ops. I learned a ton about rural economic development, and we're using all of those skill sets bringing those to the table to try to make an impact for our growers and the economy and the environment all at once.
Awesome. Yeah, hemp's the sort of the perfect thing for all of those things. So,
It do that.
all right. So today you're sort of rolling out a white paper about industrial hemp as an energy crop, specifically as a feedstock for anaerobic digesters that generate renewable natural gas, right?
Correct. Correct.
And that's methane.
Yes, well, it starts as it's methane and biogas, and it goes through the process. But ultimately, we believe the creation of renewable natural gas is the best use for the energy crop for the hemp to be used for that. So we're focused on renewable natural gas right now for a bunch of reasons,
Mm-hmm.
which we're glad to get into. But yes, that's exactly right. It's an executive summary of the findings between our really great, smart engineering team and our really great, smart agronomy team on how to put both of those pieces together to understand, hey, here's how we ought to go forward and do more energy creation by using industrial hemp.
Okay. We'll get to that research in a minute. But first, so you would capture this methane gas and then use it for energy and heat, and it would just sort of like plug and play into the existing natural gas infrastructure?
Yes, I mean, well, obviously it takes a whole lot of steps to do that, but that's exactly right. So the end use of the gas would be depending on who wanted to purchase the gas. So one of our current customers wants the natural gas itself to go directly into their processing facility because they are doing a really cool environmental processing of waste streams at a project that we're doing in Missouri. So they're going to go straight to gas on that. Others may just be brokering the natural gas that then could be sold for end use number 2 or 3, which could be conversion into electricity as part of the electric generation process, or it could be making biofuels or biodiesel, or it could be making jet fuel, any number of things that you would typically already be able to do with natural gas, compressing it and being able to put it into your city bus system. All of those uses would be after us. We're not
Yeah.
necessarily making those. We're just making the gas and then getting
Okay.
it to the pipeline.
And then would that gas it would just be able to mix with regular natural gas?
Mm-hmm.
Yeah.
Yeah,
Wow.
yeah,
Okay.
that's right.
Um, is there a greenhouse gas emission associated with the burning of renewable natural gas?
No, I mean, part of that was we've developed a closed loop system where we would be able to take any of the greenhouse gases, and then primarily each system is going to be a little different because the engineering is going to be a little bit different because the feedstocks will be a little bit different of what we might put into the digester. So we expect that most of that will be turned into green methanol, which is a blending of CO2 and steam. So there would be a totally closed loop system and where we're not putting more greenhouse gases into the atmosphere by creating the RNG.
Okay. Wow. That sounds pretty amazing. Currently, natural gas does have a greenhouse gas emission to it, right?
Oh yeah, I mean all the
Yeah.
stuff you read about fracking and this, and where a lot of that petroleum based ground gases that are being drilled for and otherwise, we are replacing that or
Okay.
finding it as other uses for that. Yeah.
How does it compare cost wise to natural gas? And I know you're just in the research phase now, but how do you expect it to compare cost wise to natural gas? And I guess I mean that both in an economic and environmental sense.
Well, economic sense is that it tends to, and these are things that are done on the spot market, right? And unless you're able to go and lock in a particular price for renewable natural gas, some places it's a little higher. It depends on whether we have to transmit it or not. I mean, if we make a renewable natural gas facility, let's just say in Lancaster, Pennsylvania, but it's actually going to get wheeled over to somebody in Indianapolis. Well, that's going to make that cost go up, right?
Right.
So it is all, but yes, it tends to be a little bit more expensive, but it's I don't think this is not a price play about why RNG has got this huge amount of demand for it. It has to be because it is certainly hitting all the environmental reasons to be able to move to something like RNG instead of petroleum natural gas.
Okay, so you're imagining like local energy hubs almost.
That would be ideal. I mean,
Yeah.
the demand on the things that we have learned from the Renewable Natural Gas Coalition is that there's so much opportunity for the gas itself. There's way less supply than there is demand. So the looking out into the future based off of some of the Paris Climate Treaty goals, we're talking about millions of tons of natural gas that need to be produced in order just to be able to meet some of those goals, at least by over the next 25, 30 years.
Right. And getting back to the comparison with regular natural gas, that industry gets subsidized pretty heavily by the government.
It does, and in other places around the world, it gets very subsidized by those countries as well too. So we got to kind of think of this as far as energy and gas is concerned, as in a really a global look at that, not just about what we're doing here in the U.S.
Right.
So it's I don't know really how much gas, and I wouldn't be smart enough to pontificate on that, but how much gas that might be created in RNG in the U.S. that might be transported or gone to other countries as well. I'm not smart enough to tell you enough about that, but we're just focused on what would enough to
I'm
catch
not
us
smart
right
enough to
here in
ask
the
you
US.
about that.
That's a twofer.
How do you imagine the oil and gas companies feel about renewable natural gas?
Well, a lot of them are purchasing, tax credits and renewable identification number credits on things like this because they understand what the marketplace is demanding, and I don't think that they see this as a competitor. Look, would you rather just, monopoly's good if you can get it, right? I mean, so it's not a matter of that. I mean, it's not, but I think a lot of the oil and gas industry is moving more and more towards understanding, hey, look, we've got to be able to diversify what we're doing as far as just sources for energy. I don't anymore believe that oil and petroleum, this is just my opinion, none of that's going away. We're not going to be able to, it's not going to be replaced. Okay. But the question is, as wholly replaced, right? It's going to be, well, what other sources of energy do we bring into the entire picture? And certainly renewable natural gas is one of those very valid sources that we don't have to rely on stuff like Russia and Ukraine getting in the middle of something that ends up affecting our gas tanks.
All right. So the paper that you just released, it's not the research. You're not publishing the research, but you're sort of just declaring what you're up to in the research. So can you talk a little bit about the research and like who's conducting it? Where are you conducting it? Any sort of methodology that you want to mention?
Yes, well, this is just the executive summary. This is the teaser, Eric. So you can have us back on again later once we start releasing all of that. And we will be releasing all those parts and pieces about where the methodology came from, where all the research happened, what papers we used. Our team of our engineering team at Lucke Consulting Technology Services, our engineer's name is Eberhard Lucke, and Eberhard is helping us design the systems for the current letters of intent that we have already for the purchase of RNG. And then also coupled with his engineering knowledge comes from our chief agronomist, who's Dr. David Cornett. And he's using his PhD in agronomy along with Eberhard's engineering work. And so we have to kind of look at both sides of this, right? So this is not just energy on its own from an engineering sense or just from a plant physiology. How do we put that chocolate in each other's peanut butter to be able to make the thing come together? So they went through about 85 different research papers from across the world that have been done over the past, I think maybe 15, maybe even some of them 18 years ago, that they are taking bits and pieces and parts, and they've been able to pull that together for us to be able to make the claims that we're showing here about inputs and output ratios and how many millions of BTUs are created and CO2 capture. So we really see this as an ongoing opportunity to continue to talk about hemp for energy, and including as we would have done in our sixth grade math classes, show me your work, right? Show me how did you come up with all of that? And we will be having future webinars and seminars and other things like that where we actually will be able to show, hey, here's how we came up with these particular numbers.
Okay. So I'm guessing that there are other agricultural crops that are right now being used for renewable natural gas. What are they, and how does hemp stack up to those?
Well, some of them, it all has to do, and look, you're getting the liberal arts version here, okay? So just keep keep that in mind. But a lot of it has to do with how many sugars are actually in the plant itself, as well as other factors that help to produce energy in a biodigestion piece. So this is not a full comprehensive study of every crop that you would ever put in a digester to try to figure out whether it's the best or not best. But some of the higher end ones that are most used for energy crops are corn and fodder beets and canola seed oil. Those tend to be the higher ones that get the most bang for your buck of just strictly on the energy produced alone. So we did take those into account for the research that had already been done on those particular energy crops. So
Okay.
we didn't look at everything, but we looked at the ones that are kind of the best in class, strictly on energy production alone.
Okay.
But then there also were a bunch of other factors, which I'm assuming that it's going to be one of your next questions.
Well, I was going to ask you was going to ask you about that input to output ratio. Can you talk some about that?
Well, see, what we have to take into account is not just how much energy does hemp produce, and it's really down to how much methane is produced, right? Because we're talking about how much methane that then is produced and captured and then converted into renewable natural gas. So we can certainly talk about that. But the input output piece, we also have to think about, okay, how much energy was it that needed to be put into growing the plant itself, including the harvesting, right? We're talking about the
tractors,
the
the
gas
planting,
and the tractors,
all that stuff.
right? All of those things that you got to. What kind of energy did it take to go fertilize it, or to be able to pump water on it, or all those facts? So that would be the input. So how does that relate to the amount of the ratio on the output? How much are you getting on the output? So the input output rate for hemp is about 4 to 6. Okay, 4 on the input to 6 on the output. Okay. Corn, as an example, is about 3 to 3. All right.
That doesn't seem
too
good.
Well, yeah, it's I'm not a math major, but come on. I mean, and canola seed is about 2 to 2. Okay. Ooh. Now, fodder beets are about 4 to 7.
That's getting there.
Okay. It's in there.
Yeah.
But the question is, where all can you grow fodder beets in the U.S.? Not everywhere like you can grow hemp. How much carbon is being sequestered because of the growth of fodder beets is another point. And a third point would be, we don't want to be in the food versus fuel conversation. You are squarely in the food versus fuel conversation as it relates to fodder beets, because those are getting fed primarily to livestock. So you start factoring all A, B, C, Q to Z, that's where we get there. But just on the math itself, just on the input outputs, that's 4 to 6 based off of current planting standards, Eric. So go back and think, well, what would happen then if we started to plant and have the data for regenerative ag practices, right? Which is something that we care about. Yeah. So let's just say that we reduce those input cost of energy because we're doing it for regenerative ag. Do we want to do that? Heck yeah, we want to do that. Do we have the data sitting here today to be able to show you what that is? Heck no, we don't. Do we want to have more data to be able to show that? Yes. And that's why this whole process is kind of a breathing, ongoing opportunity for us to continue to dial in and learn even more about what that ratio can be. So if we can start with, you know, input outputs right now just based off of traditional practices. And some of that we have to kind of take into account, was this practice, what were the seed number of seeds per hectare, per acre, per all of that, planting
Lot of
pieces,
moving pieces
a
there.
lot of
Yeah.
moving pieces. So we're just kind of putting a stake in the ground of having something to measure against.
Okay. So what like scale do you imagine this at? Like how big of a scale for this to be, effective and and how soon could it be a practical and widely used source of energy?
Well, I think that most of the biodigestion that's taken place has been kind of on farm, right? And it's been kind of smaller biodigesters that probably used animal waste, manure, things like that to be able
Mm-hmm.
to generate, and maybe some other biomass and other stuff that would be, a part of that kind of kicking it in. Um, to build a facility to scale that we will need to be able to produce the amount of RNG, at least in some of the LOIs that we have in our hand right now, or LOIs that we have just almost in our hand once they get lawyered up, right? They're going to take anywhere between 14, 15 months to be able to build a facility that large. Okay. And that doesn't even take into effect what the heck it may be because of supply chain issues and things like that. So, how quickly could we do it? As quickly as we could do it. I mean, I know that's kind of a flippant, silly answer, but I mean, we're ready to go on a couple of them. Uh, uh, right now, we're right in the middle of getting a lot of stuff sourced and being able to figure out exactly which biodigester. And some of these are also where we have different investors that are involved in being able to pay for that too. So
Okay.
I would say, our first facility that we're working on the most there in Missouri, my guess is we're going to be 18 months before we're actually producing gas.
Okay. Which in the long run seems like a short amount of time.
Yeah, yeah. And that's because the technology that actually produces the gas and does all this, as our engineer has informed me to help me to understand, a lot of this stuff is not necessarily off the shelf technology, but it is widely used and already very much integrated. We're not talking about doing any research and development on a better mousetrap to make the gas. There's enough; those processes have been proven
Right.
well enough to know this is how it works and
Right.
this is what you can do to be able to produce the gas. So we don't have to do R&D, which is great.
Would you be competing with other sectors of the hemp industry?
I think only, well, first off, we would never put the grains or the seeds into the biodigestion, right? It's got way too much value. We would never want to be able to do that.
Hold on a second. So I
mm,
learned from reading your executive paper that
yes,
you would want to harvest before you even got to the flowering stage because when
ideally.
you want to use I guess before it goes into flower it has more cellulose and that's what's going to make a better energy intensity.
That's correct.
But once it goes into flower, it starts to produce a lot more lignin, which then has a lower energy output.
Bingo. That's
Yeah.
exactly correct. So,
All right.
so
So you would kind of be competing with grain in that sense, no?
we could be. I mean, we could be in that sense, but for our growers, remember, I mean, if this is all that the co-op was doing, then I would say we might be even more competitive with that. But because we also are doing grain and seed, and we also are doing bioplastics, and we also are doing, fiber for, a host of different reasons, and herd for hempcrete and all of that, I don't think that we are competing head to head. Could it very well be that we have other sources of feedstock that we put into the biodigestion process? Absolutely.
Hmm.
And so we want to be able to find that right balance for our growers between, okay, here's how many acres we need to be able to grow specifically to go for energy. But that doesn't mean we wouldn't grow another X acres for another process of what we're doing for seed, or another one, or grains, or another one that we might be able to do for fiber. So
Okay.
I would say the more that the demand for the supply gets cranked up to really meet the greater global hemp need for what we would do, might we be a competitor at that level? Could, yeah, yeah. But at the same time, for our growers at least, which is who we focus on, how much revenue is that putting into their pocket? How much wealth is that building? If we've got a facility that's going to throw off $8-9 million net revenue a year, being able to create versus what we might be able to do to make, some good textiles with, well, we like the opportunity to have that mix.
Right, right. And if we're talking about a time when those sectors are competing, that means it's already at scale, and that's a good thing. That's a good problem to have.
That's exactly right. It'll be a while.
Yeah. Can you talk about the energy output? Like an acre of hemp. What would that look like? Like, give me some kind of tangible thing to wrap my mind around.
Sure. And this is whenever we put together documents and information about things like this, we always want to be able to do what we call internal to the co-op. You got to nick this thing down, okay? Which means you got to be able to say it for somebody like me who is not a technical person, who would like to be able to know more about about how it all can work. So just to give you an idea, right? So we kind of measure things in BTUs, because BTUs are kind of, at least for the non-technical person, I think is kind of a measurement that maybe we can't draw it out on a piece of paper, but I comprehend it, right? That
Yeah.
a BTU is energy, and
it stands for something, right?
It stands for something, British thermal units. But so each acre of hemp, if it's grown at like industrial hemp, not CBD, okay, but if it's grown under industrial hemp, gives off about 208 million BTUs per acre. So 1 acre is about 208 million BTUs. Well, what does that mean? If you converted that 1 acre then of that 208 million BTUs, and you converted it to electricity as comparable to the amount of energy that's coming out, okay, it's comparable to 60,000 kilowatts of electricity. I'm just talking about the energy that's coming.
1 acre, 60,000
kilowatts.
60,000 kilowatts.
60,000 kilowatts. And
wow.
That, just so you'll have a way to put that into context, a clothes dryer in your house is one of the biggest energy hogs that you have in your home. It just, because it's heating, right? And it's turning it so that
mine runs on natural gas.
Well, hooray. Okay. So if you use it through energy and you do it through electricity, right, for that, then that's enough electricity to run a average clothes dryer for 24 hours a day for 27 months.
Whoa.
Okay.
That's a lot of dry clothes.
That's a lot of dried clothes. That didn't even count your overhauls, which you may want to go put out on the clothesline and let them be able to dry out there. That's exactly right. So that's
wow.
I mean, look, you can use light bulbs, and there's a little calculators that you can play with all
sure.
that. But 60,000 kilowatts of electricity are the same amount of energy that is being output from 1 acre of hemp because of the amount of methane it gives off.
Wow.
That's another reason. I mean, we didn't just pull hemp out of the sky. I mean, because we thought, this is because we happen to be the hemp co-op. I mean, we're focused on this because it will do what it will do.
Right. Right.
Plus the obviously things that you and our listeners and other folks all know about on soil remediation and carbon capture. You go throwing that in on top of all of it, plus the demand for renewable natural gas. Things are kind of starting to line up as why we would want to be in the middle of it.
Right. And we just have to reiterate regenerative ag practices, because as soon as you plow that field again, you lose a lot of the carbon. So if we're talking about carbon sequestration, we have to talk about no-till.
Yes. And some of those practices, again, are going to be based off of, what is our end user looking for? We're expecting and hoping them that they will be using to know that we are planting under regenerative ag practices, that's part of the reason that we're doing it, right? Not just the carbon that's sequestered above ground, right, but by the hemp itself, but also within the soil itself too. So all that's on the table.
Okay. So would this hemp that you're using for, methane generation, would you need to process it, or would you just take it straight from the field and dump it into your digester?
Yeah, I mean, some of that some of it's going to need to be dry weight, so there's going to be some retting that'll be involved in there. There are some conversations about might we get even more methane yield if we did some type of breaking down of the material before it even got into the process.
Okay.
Well, if we broke that material down even more, are those chemicals that we would be putting in there? And if there are chemicals, are those bad chemicals, or where
Mm.
did those bad chemicals come from? And what would that look like? And do we really balance out? And we don't want to get into any greenwashing, right? I mean, we don't want to get to say, oh, well, we could increase yield and have, instead of 208 million BTUs, you could have 215 if you just add this. Well, who wants to add the bad stuff into there so
Right. We're looking to get away from the bad stuff in this whole
right. And
paradigm
so
shift.
that's not. So that may be a longer answer than you wanted on the question, which is typical of
I'll
me to
just edit you
give.
down to a couple of words.
But so we don't, it is all going to depend on the feedstocks that are coming in. And so each feedstock, and by that we mean different sources of biomass. It could be sewer sludge, it could be animal waste, it could be other cellulosic material like sawdust or things like that. That we are expecting that we will mix the hemp with some other feedstocks in order to be able to generate the amount of methane that we want to create in one particular facility. We don't automatically assume that it will be 100% hemp. We're assuming that there might be other sources of feedstock too, and that will determine on the question about how it needs to be processed. The hemp needs to be processed. So
Okay.
we're expecting that we could just go chop it and put it and put it straight into the feeder.
Is there a byproduct from your process,
You
or
mean
or
other?
a waste product? Like once you,
Yes, but there's a little bit of ash that can happen through the process, but it's inert. I mean, it doesn't have any value to it really. I mean, and it's nothing bad that comes from it or something that would cause us to be able to not be able to dispose of it. But it's kind of inert ash material that could be used in a roadbed or could be used
hmm,
in maybe mixed. We're exploring. We don't know the answer to this, and we would love more R&D on that. Is to say, well, what if we took that maybe with some biochar, something else as a better binder that
hmm,
could be able to be
okay,
used for as a regenerative fertilizer. But we're not there yet. Don't hear me
okay,
say that's what it
all
is.
right.
But
But it's an idea for some enterprising young entrepreneur who,
heck yeah, who
yeah,
would like to be able to come in and work with the co-op for us to have another business unit to just to be able to take that stuff. We'd be glad to do that.
okay, all right. So, what are the next steps? What's happening from here?
Well, from here, then we are continuing to work on our current letters of intent that we have from purchasers of the renewable natural gas. So once we know that we've got a facility that is going to be located in X spot, then we are able to use that opportunity to go back out to the growing farming landowning community and see who would like to help us bake this bread, as they would say at the Little Red Hen, and who else do we want to be able to find that source of biomass for. So we'll be starting to source that, figure out what that looks like. We would like it to be co-located in a place where we are already doing other value add for other things. So, it's not just being able to do only for RNG, although that's plenty and that's enough to keep us all happy and smiling and moving forward. We would like to know that our growers are going to be able to grow for other end uses as well, like grains and processing into cortication and part of that as well.
Okay. I think you sort of answered this question already, but I'll ask it again anyway. Um, how does this research and technology benefit farmers and members of the National Hemp Growers Co-op?
Well, this is another source of revenue that goes into their patronage payments. and it fits within our co-op model, which means you don't have to be growing hemp locally and have and only to be able to benefit from your patronage payment. So again, if we had an RNG facility in Lancaster, Pennsylvania, our grower of ours in Las Cruces, New Mexico, still is going to have that as a part of her dividend payment, as part of her patronage payment of the revenue that's coming from that facility. So the more value added things that we continue to add to our pipeline and to the things that we're working on from the co-op, the better. This one, though, happens to be much more financially lucrative than some of the other processing that you might be doing with maybe a typical decortication facility.
Okay.
Because fortunately for us, there is more money for investors than there are projects. So finding I don't want to make that sound flip, but finding the money from the right folks who want to be able to invest in renewable natural gas is not our is not a huge challenge for us. We got to find the right partners and got the right people we want to work with,
Okay.
but it's not our biggest worry.
All right. So this research just sort of exemplifies why somebody should consider joining the National Hemp Growers Co-op.
Well, I would hope so. Yes. I mean, and then not just of what we're doing because of RNG, but also because of the other benefits that we have from the co-op, such as lower input costs because we're group purchasing, because you've got a patronage payment that is derived from places and end uses all across the country that I think that this is yet another incentive, and it certainly helps to go to the bottom line to understand, well, how much would my share of stock be each year. It certainly when you can build on a facility that might be somewhere in the neighborhood of 85 to 90 million dollars to create and to build, but is throwing off somewhere between $9 and $10 million in revenue every year. Again, you don't have to be the math major to figure out, that ain't a bad return.
Where can people learn more about this?
So if somebody would like to have a copy of the white paper, the executive summary, we'll be glad to send that to them. They can go to our website and find this information there at National Hemp Co-op, all one word, .us, or they can email us to contact at nationalhempcoop.us. And we will turn the paper back around to them, and they can stay on our mailing list and learn more as we do even more R&D, more research as we keep dialing in the knobs, as well as releasing more information about kind of, like I said, show your work where all this information came from.
Awesome. Nick Walters from the National Hemp Growers Co-op. Thank you so much. It's always great to talk to you.
Thank you, Eric. We love spending time with you. Appreciate what you do.
So there you go. What do you think about hemp as an energy source? I would love to hear your thoughts on this, so please reach out to me. You can always email me at podcast@lancasterfarming.com. Okay, next up we're going to talk to Lori Daitner from Dawn Services in Newcastle, Pennsylvania, where they just recently finished the Project PA Hemp Home. That's where they took an old house and they renovated it using hempcrete and hemp wood, and it's pretty awesome. So we're going to check in with her and just see what's happening. Hi, Lori Daitner. How are you doing?
I'm doing very well, Eric. How are you?
I'm doing okay. Hanging in there. Maybe listeners remember you as one of the people involved in the Project PA Hemp Home, which was one of the very last stops that my family and I made on our way home from the big national road trip last summer. And when we were there, the house, I think, had already been sprayed with hempcrete, but hadn't been plastered. It was still like a very, very much like a job site.
Right.
But from what I understand now, it's actually a livable home. So can you sort of bring us up to speed as to what you did since last time I was there?
Sure. Well, there was a lot that went on. By a lot, I mean a lot of learning. Um, we had to figure out how to do the plastering with our crew because of, budget and also the fact that it's really hard to find a professional plasterer who can squeeze you into a schedule because they are booked months out, which speaks to the trades and how this can impact them going forward. But we had a lot of learning on that plastering part. It did take quite a while for it to dry, longer than we expected, because we had an incredibly wet August
Hmm.
last year, unseasonably so for us. But we did get it finished. The house on you, as you may remember, is clad with locally produced and locally sourced hemlock on the outside, with an air gap between that cladding and the hempcrete insulation material.
Hmm.
So that part was done. We got the interior plastering done, and then all of that great finishing work that had to happen, including installing, which was a super exciting moment for us, installing the hempwood flooring that we had created together with Greg Wilson of Hempwood
Hmm.
from the harvest of our 2020 hemp test acres program.
Nice.
So that is super thrilling. And when we finally were able to invite Pennsylvania Secretary of Agriculture Russell Redding to come see the house, and he took his first step in, and I was able to say, "You're standing on Pennsylvania hemp." I got to tell you, that was really a moment. I mean, there were a lot of moments along this whole process, but that was really a moment.
So maybe we sort of like zoom out a little bit and just can you describe sort of what the project was?
Mhm.
Like, why did you do this?
Well, we did this as part of our work to launch a decortication facility. Um, that's where we are in the industry still in so many ways, where we have to not only just do our due diligence on, okay, can we afford this equipment? Can we run this facility? Will it pay back? Will it be self-sustaining? Um, we have to work at the market itself. So this was part of working at the market, showing the potential of hemp in building materials. And we wanted to do it in several directions. We had considered using hemp fiber wool batting, hemp fiber wool batting insulation as
Right, right.
well. We ultimately did not do that because of budgetary reasons and some timing issues. But we did manage to have the hempcrete in and the hempwood flooring, and we have tried to promote this as widely as we possibly can. And we're not
Right.
the only ones doing that, but we needed something here.
Sort of like proof of concept, like this could work
Yes.
here in
Yes.
Pennsylvania.
It's such a difference when a legislator who hears about hemp and that message is crowded with all the other messages coming at them from so many different directions. When that legislator can step into the House and say, oh, wow, I really get it now. And that's always an aha moment, no matter
Yeah,
which legislator or elected official has come through that House.
right. Seeing is believing.
Yes. And
And
touching. You can touch
yeah,
it.
right. And there are so many, houses in Pennsylvania that need to be sort of refurbished, right? Like we could
Yes.
make all of our existing houses these energy efficient, wonderful, healthy homes. And we
Yes.
could do that with an agricultural product grown in the state. So it's
Yes.
just like, for me, this is like, I'd love it. And I would love to see, hemp homes all over the place. You are pioneering things out there at Dawn Services, Dawn Enterprises, the Dawn
Oh,
Group,
the Dawn
all of the.
Group. The Dawn Group. We have several companies within the group. I think we've covered this before, but I always like to let folks know what Dawn stands for. It
Mhm.
stands for Disability Options Network, which is the core nonprofit in the group and the core of what we have always done, what we do now, and what we will do. Everything that we do feeds back into supporting that nonprofit.
That's awesome. It's just like there's a lot of heart at the center of what you do. And it sounds like there's just a lot of love there. So thank you for that work. That's what we need. We need more of that in this world.
I'm very, very blessed and honored to be, a part of it. A lot of times folks don't understand, well, how does hemp feed into disability rights advocacy? Well, it does. It creates jobs. It lifts a community, providing economic opportunity for our agriculture neighbors. And when you lift a community, you lift everyone.
Last week I was talking to Greg Wilson at Hempwood, and I heard before that there was some talk of bringing maybe a hempwood factory up to Newcastle in Western Pennsylvania, and he said that's still in discussions, and so
Yes.
that's exciting. I mean, Pennsylvania is like perfectly located to so close to all of the markets up and down the East Coast. We've got great farmers, and so yeah, I'm hopeful that that works out, and if any of our legislators or policymakers are listening, help this project out, please. Right?
We would certainly appreciate any help. It is still very much on the forefront of our of our work. We would be super excited to pull this off. We do want to do it right, which is why we are working at it so diligently.
Right. Good. And I imagine we will see you at the Pennsylvania Hemp Summit in about about a month and a half away from now?
Oh, goodness. Yes, it is that close.
Yeah, it's coming up.
Yes. I will
So,
be participating in the legislators panel. There are a group of us who will be interacting with legislators. It is a session aimed at education, giving legislators an ability to ask questions directly of folks who are working in different facets of the hemp industry. So we hope that it will be a very productive session and help move the dial on some of these projects that we're all trying to do.
good. Yeah. And listeners will hear more about the Pennsylvania Hemp Summit in the next few weeks here on the podcast. One final thing. Is there someone living in the Project PA hemp home now?
As of next week, she will move in.
Oh,
Yes.
great. Okay.
Yes. And she has been super patient, but diligently and very excitedly following all of the progress on social media, both on Facebook and on Instagram, and kept herself informed, learned about the products used. Parsons School of Design's Healthy Materials Lab created a new homeowners user manual for her with things in there about how to care for the plaster, the linseed oil paint that was used to reduce to actually eliminate some of the toxins that are in typical homes, how to care for the hemp wood, and to even including chemicals, what kind of cleaning chemicals she should be using in general to reduce all of those toxins in the air.
That's awesome. That must feel just really good to, see that project come to fruition and know that someone is going to be enjoying that.
Sure. And we will be publishing very soon the air quality testing results, as well as the results from Pennsylvania Housing Research Center's work on the thermal resistance of the hempcrete walls.
Oh, cool.
So more to come.
Awesome. Well, we'll check back in with you as time goes on. Lori Daytoner from the Don Group in Newcastle, Pennsylvania. It's great to talk to you.
Oh, my pleasure. Thank you.
All right, there you go. Here we are at the end of the show. I hope you enjoyed this one. I know I did. There's a lot going on today's show. You heard me mention to Lori about the Pennsylvania Hemp Summit, and that's coming up November 14th and 15th in Harrisburg, Pennsylvania. I will be talking a little bit more about that in the coming weeks, but it's looking like it's coming together. It's going to be a good show. If you were at the 2019 Pennsylvania Hemp Summit, you might remember that we did a live podcast from that reception, and we had a live band. The Tin Bird Shadow was in the house. So I think we're going to do the same thing this year, but we're going to do it in a bigger and grander way. You can go to pahempsummit.com and you can learn more about it. You can register for the event. I think you get a discount if you are a Pennsylvania hemp permit holder. So there you go, save a little money. All right, anyway, that does it for me today. My name is Eric Herlock. I am the digital editor at Lancaster Farming newspaper, the greatest agricultural newspaper in the world. Check us out online at lancasterfarming.com. Oh, also check out lancasterfarming.com because we did a total redesign of the website. Just launched it last week, so check it out. Let me know what you think. Our team has been working really hard on this to bring our website into the modern era. No more animated GIFs, no more dancing squirrels. Nope, none of that stuff. It's all slick, it's all good, it's all Lancaster Farming all the time, lancasterfarming.com. All right, until next time, I will see you in the newspaper.
industrial hemp.
Season 2, Episode 37 of the Lancaster Farming Industrial Hemp Podcast is copyright 2022 by Lancaster Farming newspaper, part of the Steinman Communications family. Today's show is written and recorded, edited, and produced by Eric Herlock. The music you hear throughout the show is courtesy of the Tin Bird